So if I go back and I look at that problem, I will see a diagram that looks like this. And I'm going to re-look at that diagram in relationship to the problem at hand. A corn is stored in a cone-shaped pile that looks like that. The diameter is 82 feet. So I'm not using 17, I'm going to use 82 for my diameter. And the height is no longer 11, it is 20. What's your radius? What trig function are you going to use? Go to the next problem. What else? Pressing buttons in Z calculator.
That's always fun. I don't know, the answer that I got wasn't between 180 and 270.
It's not going to. When you go through this problem here, remember the cosine, when you press the buttons in your calculator, cosine is going to search for a theta value between 0 and 180 degrees, between 0 and pi. When I press inverse cosine, cosine of negative 0.72, I get an angle of 136.05. So that comes over here to 136.05. Now, how far is that from the x-axis? What's its reference angle? Its reference angle is 43.95. And now you need to place that same angle into the third quadrant, means you just add 180 to 43.95. $223.95. That should have been your answer. The calculator will find it within the parameters set, and then you just bounce it to a different quadrant by using the reference angles. Yeah, you just forgot. What does the altitude do? Perpendicular. What does the altitude do to an isosceles triangle? It bisects the base. So what trig function are you going to use? What trig function are you going to use? Sine. No. Shimkey! No!
Okay.
What's up, Shimkey?
For the last one, we did 49.
Yeah.
If we just do 360 minus that angle, we're going to get the same answer, right? Like, not 46, like the 135 angle that you get the first time. Can we do that or no? Because that's what, so I just did 360 minus 136. Is that going to work? Because I got the same answer.
Okay. It does because of the cosine value and obtuse.
Okay.
Don't do that.
Okay.
Okay. You made the wrong mistake. The wrong mistake. Don't do that. All right. Because remember, reference angles are going to bounce off that, but by the fact that it's an obtuse angle in the second quadrant, if I had an obtuse angle going the other way around, it's still going to bounce into the same spot. It wouldn't work if it was an acute, because then you'd have over here, and then you'd have to come over there. Don't do that. Use reference angles. What else we got? Yes, ma'am. What angle has a tangent of negative root 3 over 2? So, what angle has a tangent of negative root 3 over, was it root 3 over 2? 3. Sorry. So now, what triangle has the root 3's? 60. So, which one of those gives me a tangent of root 3 over 3? 30. But it's negative. So, that means it's going to be negative 30 degrees or negative pi over 6.
Well, I made a mistake.
Yes, ma'am.
So it's okay that the answer is negative, you don't make it 300 degrees.
No, because again, what are the parameters set forth for inverse tangent? Between pi over 2 to negative pi over 2. There is no 330 degrees. Okay? Bless you.
So with these, like I did these right, I think, but with these, you just have that arc, and then if it's negative, you go on the negative side, or the negative side,
Mhm.
if it's positive, you go on the positive, and then that's all.
That's really all it is, man. That's it. That's really all there is to it. Oh, I didn't even catch that. That's funny. Yes, sir.
How comes 70 to 360 is not degrees?
We look for the first period. You'll see more of that from this graphic. It makes you'll understand that more. You see it. What else you got? Did you figure out the gate, the bridge?
We had a bridge problem.
Yeah, we already did
We didn't have to do it.
We have to do that one.
I didn't make you do this?
No.
Oh, son of a.
Homework,
Son of a bridge.
Oh, that's scary.
What'd you do on 55 then?
I don't know. I got like the tangent of.
You double it?
Yeah.
I just got to
I thought I had you guys do 56. I didn't make you do 56. Darn it. I love that.
Look a lot like 5.
I love the bridge problem.
Give that one just that one touch over. Except add your own twist to make it.
Wow. I should make you do, hey, do 56 real quick.
Let's not.
Yep. Try 56. California. It's a double leaf drawbridge. Goes up and down. Each leaf of the bridge is 120 feet. If a ship that is 100 feet wide needs to pass through the bridge, what is the minimum angle theta the bridge has to be open to ensure that it fits?
What?
Read what?
Why not just be safe and just
You should be.
Okay. So let's do this. So I need to do this space. May I? I hate to kind of boost some stuff. Put your arms up on your elbows. Lower the bridge. Oh, they overlapped, didn't they?
Yes.
Spread them apart. Your fingertip to fingertip, and now open them up. It's a lot further in there. So when the bridge comes down, what's the width?
It's extra. Oh, 220. Oh, snap. Oh, boy.
So you've got your.
120 on each side, and then
So this whole part is 240,
120.
but that much is 100.
Also, it's a 45
So
No.
just subtract 100.
It's minus
240, and then you divide it by 2.
Because if 120
70 on each side.
minus 150 by
So it's 70 here.
Someone from Texas is calling me.
What trig function you're going to use then if you've got 70 on your adjacent and you have enough hypotenuse of 120? Hey. Thank you. I love this problem. That's a great problem. Not for us. Okay? You just use cosine. You have to use cosine to solve for theta. Okay.
When we open it up and actually check for
You guys get 154? Hey, you get 54? Anybody else get 54?
Yeah.
Yeah. That made sense.
Any other questions?
Why is the sky blue?
Reflection. Refraction, something like that.
Fraction of light.
Get off my paper.
All right, make sure your name's all right, send it up. Where'd my notes go? Nomenclature of how some of this stuff is written. Another way we write this stuff out, instead of sine to the -1, cosine to the -1, things like that, we can call it arc sine, arc cosine, arc tangent. All those mean the same. What angle pass? Okay. You see it written as arc sine, arc cosine a lot more in pre-calc, but I wanted to show you like that because I'm trying to mess with you guys a little bit. Yes, ma'am? Cosecant is the reciprocal property of sine, whereas the inverse is what angle has.
Wait, but when you put it in the calculator.
No, we worry about that pre-calc. We worry about all that later. Okay. So I'm not going to concern about that yet. Yes. Yeah, good, but I still need to. And you'll see when we graph. All right. When you graph sine and cosine, and I know I showed you guys this earlier. Remember how I said that sine? We know on the unit circle, if you think about the quadrantals, at 0, it's sine was 0. Pi over 2, it's 1. At pi, it's 0. 3 pi over 2, it's -1. And then back at 2 pi, it's 0. So sine would do this. For the ordered pairs, you're at 0, 0. This is pi over 2. And, well, let's just think of this. Yeah, pi over 2. And 1, 0, 0. 3 pi over 2. And -1. And what would that be? 2 pi, 0. So what happens here?
How was it 0, 0 twice?
Oh, I'm sorry, pi, thank you. Sorry. So what happens is, if you think about it in terms of unit circle wise, you just go back to x's and y's if you want. Reciprocal properties, unit circle, 1 and 0. Sine would be y over r. You agree?
Yes.
Cosecant would be r over y.
Yes.
So what's the reciprocal of 0?
0. No, that's an error.
Undefined. It's error. It's undefined. So you get then an asymptote. Let me see if I do it like this, you see it better. You get an asymptote at 0. What's the reciprocal of 1?
1.
1. Is it 1?
Yes. Wait, are you not sure?
I'm joking. What's the reciprocal of 0?
0.
Undefined.
So again, I have an asymptote. What's the reciprocal of -1?
-1.
What's the reciprocal of 0?
Undefined.
Since it's graphing.
And this is easy.
Okay? Right now, I've got, instead of 3 zeros, I have 3 asymptotes.
Yeah.
Now, here's what happens now. Somewhere in here, we knew that sine is equal to a half. What angle has the sine value of a half?
30.
30 at pi over 6. So at pi over 6, you've got a sine value of a half, but what's the reciprocal of 1/2?
2.
2. So the cosecant of pi over 6 would be 2. Again, on the other side, at 1 second here, at 5 pi over 6, second quadrant, I still have a sine value of 1/2. What's the reciprocal of 1/2?
2.
2. So what happens with cosecant? Cosecant flips inside out of a sine
That's kind of cool.
because of the reciprocal properties.
Is the dots on the asymptotes are those being open?
But yeah, we'll worry about that later. I'm not too concerned about open closed dots. All right. Yes, sir.
Like I understand how you're getting all of this, but I don't understand what exactly I'm like looking at.
And that's okay. His question was, can you calculate cosecants via angles? Yes, you can. And it stems from going off of the circle, knowing that at 0 the reciprocal is undefined, reciprocal of 1 is 1, undefined. Your fractions just become flipped. It's just reciprocal property. That's all. And we'll worry more about this later. This is just a quick little question that he had.
Okay, I want to.
I'll get you next. I'll get you.
I'm assuming that they're not exponential functions for the asymptotes, or is that?
Yeah, they're getting closer and closer.
So then how are they the inverse of sine, because the inverse of sine would be getting. Oh, yeah. Never mind.
Good question. Yeah.
So this is a circle and it's always two times that and everything. It never shifts. So
Oh, yes, it does.
It's
Bro.
shifting sine functions?
The sine is then the secant incest.
We'll learn all about that later.
But that's just.
The basics, yeah. And it stems from the 5 points on the unit circle as you go through with sine, cosine. Tangent's a little bit easier. There's only 3 points on the unit circle because then you have asymptotes at pi over 2 and negative pi over 2. And then the other ones just happen to float between. Sine and cosine graphs are continuous functions, whereas tangents have breaks. They've got asymptotes.
So how come they meet at the bottom of sine and top of the cosecant?
What's the reciprocal of 1?
Oh, it's 1.
Yeah.
Oh.
Don't get hung up on this right now. We'll worry a lot more about this later. What I just wanted to show you guys is the nomenclature, the labeling, arc sine, same thing as sine inverse or negative 1, what angle has. Arc cosine, what angle has. Arc tangent, what angle has. All means the same, okay? So you can do stuff like this. Yeah. Arc sine root 2 over 2 means the exact same thing as what you did yesterday. What angle has the sine of root 2 over 2? 45. Same thing.
Is this continuing for 2?
Yeah, I'm adding a little bit of extra to it with the different ways of writing it, and I'm going to do some combination functions as well. And don't forget, anytime you're working with arc sine, arc cosine, or the inverses and whatever, if you think that, you are always going to give me 2 answers, degree radian. Okay? You always give me 2 answers, degrees and radians. With that, I can do this. What is the sine of the arc cosine of a half?
30 degrees.
Ah! You don't get a calculator for this. Think about order of operations. Order of operations tells you to go where first?
Parentheses.
Parentheses. Okay, what angle has the cosine of a half?
30. 60.
45.
Holy crap, we need to draw this stuff. You guys know we're having a test on Thursday, right?
Oh,
Okay. Can't do it Friday because it's ice cream social, and you guys don't want to take the test on a Monday, trust me. Which angle has the cosine of a half? 60. What's the sine of 60?
Sine is
2.
Oh, it is root half.
3 over 2.
Yeah.
Working inside out. What angle has the cosine of a half? What's that angle's sine? Just go. All right.
So it goes in the angle, so you find the flux one, the
Yeah.
cosine.
Yeah, it's just order of operations. Working inside out. Yes, sir.
Okay, so the inside. Yeah, it is 60. It's it's cosine. Wait, can I take that back?
So what triangle has the what halves?
30, 60.
Okay.
I got this. I swear to God.
What angle has a cosine of a half? 60. What's the cosine of 60?
So they
So they cancel.
Yeah.
Pi over root.
It's the inverse, so it cancels it out.
Okay. Oh, I like this.
I'm stupid.
I don't know why it took so long on that one. That was kind of funny. what angle has the sine of root 3 over 3, and what's its tangent?
Whoa.
I wrote it down.
Yeah, it's sine. That's tangent.
Did I write that? Did I write that down wrong? I think I wrote it down wrong. Should be. Sorry, it was 2. Sorry, it was 2. That was the wrong one. Okay. What angle has the sine of root 3 over 2?
60.
Okay. What's its tangent?
Root 3.
Yeah, I garbled up 2 problems.
Oh no.
It's the same thing, we good, it's okay. Look, this is some baby. This is out of the world. Oh, I see. This has like a D on it.
Minus.
Again, you are working inside out. What angle has a cosine of root 2 over 2? 45. In other words, pi over 4. So then you have, what is the sine of pi over 4 minus pi over 4?
0.
What's the sine of 0?
0.
What's up? Yeah.
Not my life, that's for sure.
Okay.
Sine.
Yeah, somebody got really, really bored. They mix it up a lot.
Yeah.
They mix it up.
Looks so confused.
Why?
No. What's the tangent of 0?
You really just gotta give us
I mean,
Well, what? Arc sine and sine? Arc sine means what angle has. Sine is what's its order direction. What's the value of y over r?
And then how do you put the S and G in?
Depends on the quadrant. It came full circle.
you guys are so bogus.
You're bogus.
Shut up.
Huh?
That's not funny.
You guys okay, 0?
Yeah.
Hello. What does it equal?
47.
What angle has the sine of root 3 over 2? 60. What angle has the sine of 1/2?
30.
What's 30 plus 60?
Oh, yeah.
Momento.
You don't like this, do you? You're kind of giving me
It's a secret.
the...
I'm digging this. This is dank beans.
There's no, the good ones are Jason, yeah.
No, that's a problem.
Oh, no, do you?
Is the answer 90 or 91?
90 degrees, technically.
Which one did we use the opposite of? Yeah, because you get opposite over opposite.
Order of ops tells you to do what first? The arc sine, right? What angle has the sine of root 2 over 2? Pi over 4. What's 3 pi over 4 plus pi over 4?
Pi.
Pi.
Oh.
What's the tangent of pi? Where does pi land?
180.
What's the ordered pair?
-1.
Y over x is
1. No.
0.
Yeah.
I heard you say the y
Should it be
tangent.
tan of 0?
What's the tangent of pi?
I just thought of the tangent of 90. Well, if the tangent of 90 is
Y over x. So this is 0 over negative 1. Ah, you're not doing the arc tangent. It's a good question. Why am I trying to find the tangent of pi? Why am I trying to find the tangent of pi? I'm not finding the arc tangent. I'm just finding the tangent. What's the ordered pair here? -1 and 0. Tangent is y over x.
Wait,
Oh,
so those
excuse me.
3 limitations were on the arcs, not
Yup.
the other.
Not to get any on yet. Okay?
I've been working since high school.
So 3 plus pi over 4 plus pi over 4 does not equal 1.
No, it means 4 pi over 4. Which is 1 pi.
Wait, so if you try to find the arcs, you don't find.
No, you're not going to get undefined. The calculator is not going to search for it because in order to find the arc tangent, in order to find the arc tangent of something, it's going to look between pi over 2 negative pi over 2.
How would it find that?
The arc tangent of pi,
Yeah.
it's probably calculating a reference point and moving across the field. Because in honesty, -1, 0 is the same as 0, or 1, 0. When you start looking at y over x. So we will test through
So it's not like this pi. It's like
Thursday test.
the 2 pi.
What I'm looking at doing is it's going to be basically calculator, non-calculator. So if it's calculator, non-calculator, you could probably figure out what the calculator part's going to be.
Yeah.
Like right triangle trig and some of the stuff you did last night where you had to actually hit the button and move it to the correct quadrant. Maybe a word problem here or there. Right? What I have decided. What's that? I didn't hear you.
The bridge problem.
No. Something else. Probably somebody like jumping over a fire pit maybe. That's always a fun one.
Yeah, we've done it.
As far as law of sines, law of cosines is concerned, I've decided to just kind of hold off on that and then just, because it's only one little blurb, you ever see it in this whole chapter, in this whole book, you actually have a use for it in pre-calc. When we get to the final, law of sines, law of cosines is generally a formula that I give you, so you don't have to worry about memorizing it. You might have to know how to figure out if you have a second triangle, that's about it, but other than that, sure.
Is there going to be something like on the worksheets when we were looking at them? They were talking about like things like following like angles to get further and stuff like that when you throw things. Are we going to have anything like that?
We haven't really gotten into, I know what you're talking about with the quadratic style.
Yeah, I guess so. Yeah.
It was a quadratic, and then we had the angular velocity style. Not so much. I'm not worrying about that. I'm looking more at the straight trig stuff.
All right.
We come back to that modeling later in the school year. We kind of do all of those big problems like that later on. So that's what I'm looking at doing on Thursday, because I know most of you guys will be out Friday during 12th hour. Yes, ma'am.
So, are we gonna get
I'm working on it. I'm gonna we have it over there. What I have is that I have a bunch of stuff from 13.2 through 13.4. I didn't really put anything in there from 13.1 because that's just right triangle trig, SOHCAHTOA. I mean, you have to use it most of the time with this stuff anyway. I know you guys teach Pythagorean theorem, so I'm not really worried about that. The one thing I did forget when I realized that I passed it out third hour, I forgot to add in the stapled part of the 13.4 stuff, the arc sine, arc cosine. So today is just basically reference angles, radian degree, positive, negative coterminal angles, trig of an angle, like what is the tangent of negative 600 degrees, something like that, where you have to bounce it to figure out into the correct quadrant and go from there. Yes, ma'am?
Is this 13.1 to 13.4?
Yeah, but 13.1's kind of like silly.
Didn't we do something like 13.9 or something?
We did 5 and 6. That was sine cosine stuff.
Exactly.
Yeah, I was just said that.
So,
Which would be good because then on Friday I can start the graph, not graphing, but I'll start with the equation stuff.
do we have to do arc lengths?
I haven't decided yet. I don't know. Maybe it's easy.
Decided we don't.
That's a calculator problem anyway. I'd give you a calculator for that. What's up, Anna?
Did you say something about see if there's a possible second page?
No. What I was saying about that is if that would be the final, because it's very simple to do something like that on a file, knowing that I can give you the formula. You just have to check that supplement to see if it exists. And I know that's a very quick thing, and we'll revisit that when we get to the final.
So you might have just confirmed this with him, but we're not switching, we don't have to find second triangles on the test? Okay. I'm kidding.
Wait, so we don't.
I get it. What?
Wait, so we're not doing 13.1, but are we doing 13.5 or 13.1?
Great.
Are we going to need to know about sine?
Wait, but
You might need to know something about sine, yes. I'm going to say that. That would probably be a good idea.
No, because he just said something I was dumb and he never answered. So I don't know.
What? 13.1 is SOHCAHTOA.
We're not doing
I know you answered before.
Okay.
Didn't I just say law of sines, law of cosines, I'm not putting on here?
Oh, you're not?
Yeah.
4 times?
Yeah.
I think. Chicky, you heard me, right? What? The new one? I saw the original. What? I got really bored watching the new one.
That was one of the best movies ever made. What did you say?
I don't think I was in the right. I was just sitting there. I was getting bored. Okay, so they're driving around. It looked awesome. It was really cool, but it was just kind of boring.
Mr. Murphy, did you like the old one with Toad? You got
You know, it says so.